All right, 7.4, exponential and logarithmic equations. So these first three are what they called simple logarithmic and exponential equations because you don't need a calculator for these. Okay, and none of these you need a calculator for. Here's a few examples of ones you don't need that for. So this first one on the left might be the most difficult, if I'm being honest with you. But if I tell you no calculator for any of these problems, you should be able to solve these without, not only without a calculator, but get a common base with these exponents. Okay, so 2 to the negative first is another way of saying 1/2. Okay, 32. 2 to what power gets us 32? It's 2 to the 5th. Power to the power we multiply. So 2 to the negative x equals 2 to the 5th. And set the exponents equal to each other when we get the same base, and x is equal to negative 5. Next one. We have ln x minus ln 2 equals 0. If I move the ln 2 to the other side, remember our rule from our previous video, we have the same log and same base equal to each other. We can just set what's inside right here equal to each other. So just x equals 2. That's it, you got it. Finally, last one. We got log base 4 of x equals 3. So change it to exponential form. 4 to the power of 3 equals x. 4 to the power of 3 is equal to 64. That's how you solve basic problems like this. All right, so we have two exponential equations. We're going to solve them. These are going to require a little bit more work in their own right. So we have the same bases on this first one to the left. So I can just set the exponents equal to each other. And then what we have here, as you may have noticed, is it looks like we have a quadratic. X squared minus x minus 1 equals 0. Unfortunately, we can't factor this one too nicely, so it will just be your quadratic formula. Check it out. 1 minus a negative 4, so it'll be plus 4 all over 2. 1 plus or minus square root of 5 over 2. And for the other one, when we don't have the same bases, like this one right here, we're going to have to use logs, okay? Your book does it a little differently, but basically the same way in its own right. So I log both sides of the equation, and then I move the exponent up front. Oh, I did not mean to move this. Better. I'm going to move that negative t over 2 to up front. And then our goal is to isolate t. So I'm going to divide both sides by log 5. And I'm left with negative t over 2 equals whatever log of 0.2 divided by log of 5 is. It actually comes out nice. It's negative 1. Haha. So then isolate t and multiply both sides by 2. And then divide by negative 1. You get t is equal to 2. And I should have put x equals right here as well. All right, so we have two more examples of exponential functions, or exponential equations, rather. So with problems like the ones on the left, we need to isolate the base and the exponent, okay? So I'm going to subtract 7 first. Negative 2 base e to the power of x equals negative 2. Divided by negative 2, we're going to get e, that was a terrible e. E to the power of x equals 1. And you're going to ln both sides of the equation. You get x times ln of e because you move the x up front because of your exponent rules, and ln of e is 1, so it's going to be x equals what? What's the ln of 1 equal to? Well, the ln of 1 is 0. Got lucky with that one. Haha, x equals 0. The one on the right here, anytime a problem that's set up like this, treat it like you're factoring a quadratic, okay? So the first one is going to be e to the x, e to the x. Right? Factors of negative 4 that add up to negative 3, just like as if we're factoring. Okay? Factors of negative 4 that add up to negative 3 is negative 4 and 1. And we're going to set both of them equal to 0. And then isolate them. You get the ln of e to the power of x equals the ln of 4. Bring the x up front. And x is equal to whatever ln of 4 is, which I can tell you is approximately 1.39. And this one, e to the power of x equals -1. Ln both sides. What do you notice right here? You can't find the ln of a negative number. So this one does not work. The only answer for this is x equals 1.39. All right, now I'm going to solve logarithmic equation. So just like with the others, we need to get the logarithm alone here. So I'm going to divide by 6 here. I'll just leave it as 11 over 6, just to be more precise. At this point, I'm going to change to exponential form. So we have 3 to the power of 11 over 6 equals 0.5x. What is 3 to the power of 11 over 6? It's approximately somewhere around 7.49. And then we need to isolate x, so we'll divide both sides by 0.5, and you'll get a final answer of 14.99x is equal to x, rather. Now we got one with ln on the other side here. So this is where all those rules come into play from our last section. So we see subtraction, so we're going to divide. So it'll be ln of x over x plus 1 equals 2. Now we need to change this to exponential form, right? So we assume it's base e to the power of 2 equals x over x plus 1. So isolate the x. I'm going to move the x plus 1 to the other side. E to the power of 2 times parentheses x plus 1 equals x. Distribute the e to the power of 2 to both terms. And this is a little tougher of a problem, but we need to move all, whenever you have multiple x's, move them all to one side, and then we can factor it out. So we have e to the power of 2 equals x minus e to the power of 2x. I'm out of space here, so I'm going to finish this one on the next slide. So since I put all my x's on one side, I did that so I can factor it out. So factor out the x, you do that, and then divide both sides by 1 minus e to the power of 2. So x is equal to e squared over 1 minus e to the power of 2. If you want to approximate the answer, you will get negative 1.16 equals x. And that is the answer. All right, so let's do a problem about tripling our investment and how we can solve this one. So let's say you're investing, you're investing $2,500. Okay? And your interest rate is very low, and let's say it is 2.5%. How long will it take for you to triple your investment? So if we triple of 2,500 is 7,500, and it's I forgot to mention it's compounded continuously, so we have to use PERT. Okay, so 2,500 base e to the power of 0.025 t. We need to solve for t. I want to know how long it takes to triple your investment. So I'm going to divide both sides by 2,500 because we need to get the base and the exponent alone, just like we did with the equation problem. So we divide, get 3 equals e to the power of 0.025 t. ln both sides. And when we do that, to bring that exponent up front, 0.025 t ln of e. ln of e is just 1, luckily, so you just divide by 0.025. And that will tell you how long it takes to triple your investment, which will be a long time. 43.94 years. Long time, yeah. With that small interest rate, it's going to take a little while to triple your investment. All right, I appreciate you. Take care. We'll see you later.